Today's lesson in our unit Plants for Food and Fiber is on topic 2, which is structure and adaptations, and it will be split into 2 lessons. The first lesson we'll look at today, we will look at the roots, we'll look at diffusion and osmosis, and our second lesson we'll look at stems and leaves. Okay, so the plant roots, they perform several important functions. First of all, they absorb water and minerals. They also support and anchor the plant so that it doesn't get blown over by the wind or washed away by water. And they also store food for the plant during times of scarcity. Types of plant roots is next. The first type we're going to look at is called a tap root, which looks like this. This is a tap root. It's got a main root, and this main root can reach deep into the ground with numerous small roots coming off of it. And those small roots are covered in root hairs. So most trees, large desert plants, as well as dandelions, they grow tap roots. The root hairs that I mentioned, those are very important because they increase the surface area in which the plant can absorb water and nutrients. The next type is called a fibrous root. It looks like this. It's a shallow system of similar sized roots that quickly soak up moisture. An example of fibrous roots would be, for example, grasses. There is a short video here we'll watch on those 2 types of roots we talked about. So root crops, such as carrots, beets, turnips, radishes, and parsnips, they're all edible roots like we saw in the video. They can generally grow in a short period of time. They have deeper roots so that they can survive in areas where there is less rainfall. And then also they can be stored for long periods of time. And these qualities are what make root crops an important part of people's diet in the world. Next, we're going to talk about diffusion and osmosis. Now, these are 2 very important functions that allow roots to absorb water and dissolve substances. So the first is diffusion. Diffusion is when particles move from an area of high concentration to an area of low concentration until they're evenly distributed throughout that area. So for example, if we spray perfume on one side of the room, we're able to smell it on the other side of the room, and that's because of the particles. The particles of the perfume are spreading throughout the whole room until they're evenly distributed throughout the whole room. So that is diffusion. There is something called a differentially permeable membrane, and when we look at diffusion a little bit more closely, this membrane, it allows some materials to pass through, but it keeps other materials out. So if you think about a mesh bag, and let's say we put marbles and sand in a mesh bag, the sand will get through the mesh, but the marbles will remain. A differentially permeable membrane works similarly to that mesh bag. And we'll take a look at that more as we continue. So next we're going to talk about osmosis. When we're talking about osmosis, it's a type of diffusion in which water is moving. So specifically, water is moving from a high concentration to a low concentration. So we have a couple of videos here to watch on that, as well as this one here, the Amoeba Sisters. And then we'll talk about stems.